The fifth one is the fact that water actually is very unstable. You take a pot of water and you put it on a stove and turn it on. What do you see right away? What forms on the bottom of the pan? Bubbles. And if you put your finger in there, would it be hot? When you first start seeing bubbles start to form, the water can still be cold. But the heat is right against the bottom and it actually will create bubbles. And water is very, very unstable. And you add a little heat, it creates bubbles very quickly. And because it forms these bubbles, water or air, air doesn't dispense heat. It doesn't transfer any heat. So if I have a bunch of bubbles around my cylinder walls, they're going to overheat because they can't transfer the heat, even though they're surrounded by a liquid. And so we need something to break that elasticity of that air bubble and make it so that it doesn't form and that we can transfer that heat. The other thing that will happen is when these air bubbles form, the vibration of that engine and the heat will cause cavitation corrosion. And I'm going to pass this thing around. Need one that's actually cleaned up a little bit. I'm going to pass this one around, and what you're going to see is on this one side we've kind of scraped the rust away, and you'll find a bunch of little holes. And this is due to electrolysis and cavitation. The water comes up and hits this, and just the friction of the water passing by causes it to electrically erode away, plus the bubbles form, and when the bubbles actually implode, the pressure causes the bubble to compress, basically implodes on itself, and when it does that, whatever it's stuck to, it'll pull. And it actually pulls little pieces of metal off and will erode this thing away. Over a period of time, that constant erosion will eat all the way through the cylinder. Pretty soon you'll start getting water in your oil.
What part is that? What's that part called?
That's the cylinder liners.
That only happens in diesel or both?
It is more prevalent in diesels, but it will happen in both. You'll see it more in a diesel engine though. And why, I don't exactly know, but you don't see it as much in gas engines. So what am I going to check? I'm working on my cooling system and I'm going to service it because I know that it's important, so I want to service it. First thing I want to check is the level. And so most of modern equipment and vehicles have a radiator. Attached to the side of the radiator will be a container, an overflow reservoir, and it has a minimum and a maximum. You don't have to take the radiator cap off of your radiator to check to see if the fluid is okay. They're designed so you can walk up and look at it. If it's between minimum and maximum on the overflow, then it is fine. Taking the cap off the radiator, all that does is either relieve the pressure that's in there or relieve the vacuum that's in there. That vacuum and that pressure that's in that radiator is what's pulling that fluid out of the overflow or pushing it back in. And so actually you're defeating the purpose by actually opening that up. The other thing is, every time I open it up, just like in the air cleaner, there's a good chance I'm going to drop dirt in there and put debris in my antifreeze, so why do that? Then you're going to drip antifreeze all over whatever's around there, so you're kind of making a mess and you're wasting time. So don't. If for some reason my cap was to fail and it wasn't doing the proper transfer, my overflow is either going to continuously increase in fluid and it will start overflowing. That's an indication I have a problem, which could be the cap. Or it's not going to draw it back in, which is going to make it over. It's either going to overflow from pushing it out, not drawing it back in, or it's going to overheat your engine. So you're going to notice a pretty obvious problem. So you don't need to pull that cap off. So don't do that. Second thing I'm going to look at is the condition. If I look at that fluid, what color is it? Is it nice and green and clean looking? Does it have rusty look to it? Is it milky looking? Does it have a film of oil on it? What does it look like? If it doesn't look clean, it probably should be replaced. The other thing that I'm going to look at is going to be the coolant temperature in that mixture. And that's where you take your little ball checker and you suck some of that stuff up and you look to see how cold does it get. How cold it get also transferred to how the boiling point. As the freezing point goes down, the boiling point goes up. And so the two of them kind of go hand in hand. That's why these check freezing point and not really boiling point. The two of them kind of go hand in hand. So I'm going to look at that mixture. Am I going to be protected from freezing? Condition of it, what are my additives, and we're going to talk about the additives that are in there. And those are, and the hoses and the level. Hoses, are they soft? Have the hoses started to swell? If they've started to swell, it's a time bomb. It's a matter of time. It could be today, it could be tomorrow, it could be in 5 or 6 months or a year. But if it continues to swell, it will break. And so swelling is an indication that the hose is starting to deteriorate, and you're going to want to replace it.